All right, everyone. Good evening. Thank you for being here today. Thank you for taking the time to join us to discuss the research and analysis that has been conducted for the Replace on Burnout policy. My name is Viti, and I'm a supervising environmental service specialist with the City of San Jose, and I'm in the Climate Smart team, which is part of the Environmental Services Division. On the call with me, I have Hannah to assist me here today, and I'll let her go ahead and introduce herself.
Hi, everyone. My name is Hannah Greenberg, and I'm an environmental services specialist with the City of San Jose, and I work alongside Viri. And thank you all for attending.
Also, just as a reminder, this webinar is being recorded. So before we get started with our webinar this evening, Hannah is going to launch our very first poll.
So we just want to gauge from folks how familiar you are with heat pump technology. So our question is, how familiar are you with heat pump technology? And that specifically, we're asking about heat pump water heaters and heat pump HVAC systems. And I'll give folks about 15 more seconds to answer. All right, I'll give folks about 5 to 10 more seconds. Okay. So these are the results, a mix of all three answers. Yeah, thank you to everyone that answered, participated.
All right, so on today's agenda this evening, we're going to have a brief background of the city's efforts to electrify buildings to date. We'll have an introduction to a Replace on Burnout policy and what it requires. We'll also share some analysis findings completed by the New Buildings Institute. And finally, we will have a Q&A at the end of this webinar. Please don't hesitate to ask questions in the Q&A throughout this presentation. The Q&A chat button is in the bar with the other Zoom function icons. We will try our best to answer some of the questions directly in the Q&A throughout the presentation. We will then take questions at the end of the presentation. And when the time comes, please raise your hand if you'd like to ask a question or speak. For any questions that we're unable to answer today, we will be sure to write them down and post an FAQ document on our website at a later time. Before we dive into the presentation, we would like to provide a big picture context of the state of our world. So just this year, the 2022 Intergovernmental Panel on Climate Change report revealed that we must limit global warming to 1.5 degrees Celsius, or else we have the potential to face food and water scarcity, as well as increases in natural disasters, such as heat waves and floods. We also have the potential to see an increase in disparities among vulnerable populations, primarily low-income people of color, that will find it increasingly difficult to adapt to a changing climate and catastrophic events, more so than their wealthier counterparts. This makes it more important than ever to work toward carbon neutrality and the electrification of our buildings. As you can see from the figure on the right, buildings account for 1/3 of greenhouse gas emissions in the city. To address this, the city has focused its decarbonization efforts in all new development. We did this first with our 2019 REACH code that mandates electric vehicle charging infrastructure and solar readiness in all new buildings. We also banned the use of natural gas infrastructure in new development. And in 2021, the city set an aggressive goal to reach carbon neutrality by 2030. And it is at this point that we began to focus on existing building electrification. In April of 2022, City Council directed Climate Smart staff to conduct research and stakeholder engagement on the prospect of including a replace on burnout ordinance in the current REACH code update. We contracted with the New Buildings Institute to complete a data analysis that aims to address the different forms that a replace on burnout policy can take, barriers and solutions to the requirements of this policy, and what other cities are doing to electrify their buildings. The stakeholder engagement is being led by the city through this week's webinars, and we are returning to council in the fall with findings. As I mentioned before, the Climate Smart team is leading the stakeholder engagement direction from council. We will be hosting 5 webinar sessions this week where we will be engaging different groups. So as you can see from this slide, we're engaging contractors, developers, labor organizations, residents, landlords, HOAs, property managers, and community-based organizations. So this gives you a sense of who's in this webinar tonight. So before we dive deeper into the replace on burnout policy, we would also like to provide context on where this direction from council derives from. The existing building electrification framework adopted in 2022 includes 4 policy options that address existing building electrification in different ways. So let's go ahead and run through them. The first policy option you see on this slide is the building performance standards. This policy establishes targets for buildings to electrify, reduce greenhouse gas emissions, or improve other metrics by a specific date. The next policy option you see on the screen is the minimum efficiency standards for rentals, which requires property owners to meet a minimum efficiency standard for their building or unit before they can receive or renew their rental license. The third policy option is requirements at time of major renovation. This option requires electric building systems at the time of renovating or building a building or a home. Finally, there is the requirements at time of system replacement, also known as burnout. This policy option requires the installation of appliances powered by electricity instead of gas at the time of system replacement. And this can be when the gas appliance is being replaced for any reason at all, including if it's being replaced because it's no longer operational, it's reached its end of life. So this was a brief overview of 4 different policy options that aim to electrify existing buildings. And now Hannah is going to start a poll on this slide.
So we just provided a really brief overview, just a 1 to 2 sentence summary of these 4 different policy types. So just off the bat, from first impression, which of the 4 policy types that we did just outline do you think would sound best or fit the best for San Jose? And I'll give folks about 20 more seconds to answer. All right. Thank you to those who answered. And these are the results. Okay, and I'll stop sharing and Viri, go ahead.
All right, so now let's get into what a replace on burnout policy requires. So essentially, this policy requires a gas appliance to be replaced with an electric appliance when the gas appliance is being replaced for any reason at all, including if it is being replaced once it's no longer operational. For the purpose of our research and analysis, we focused only on gas water heater and furnaces. And essentially, once the gas water heater goes out or the furnace goes out and is being replaced for any reason, there would be a requirement to replace them with a heat pump water heater and or a heat pump HVAC appliance, depending on which of these gas appliances went out. And for our research, we focused on applying this policy to single family homes, multifamily homes, mobile homes, and commercial buildings. The goal of the Replace on Burnout policy is to transition away from energy intensive and greenhouse gas intensive appliances for water heating and space heating and cooling. An additional goal is to introduce new energy efficient and carbon neutral technologies into all buildings and homes. These types of policies are typically triggered at the time of coming to get a permit to replace your gas appliance. You would be required to upgrade your old appliance with its electric substitute. So as an example, if you get a water heater replacement permit, you will be instructed to replace this gas water heater with a heat pump water heater. And as a reminder, for the purpose of this research and analysis, we only focused on furnaces and gas water heaters. And we'll discuss why we're focusing on these two appliances in the next slides, as well as go over what heat pump water heaters are and also what HVAC systems are and how they work. So like I stressed in the last slide, the Replace on Burnout policy focuses on space and water heating appliances. And this is because they are the most energy intensive and generate a large volume of greenhouse gas emissions because they're not powered by natural gas. Because they're powered by natural gas, which is primarily composed of methane, and methane is a greenhouse gas that traps more heat in our atmosphere than carbon dioxide. So as you can see on the screen, these are the two appliances that we are focusing on for the purpose of this research and analysis. The first is the furnace. So under this policy, a furnace would be replaced with a heat pump air conditioning appliance, and a gas water heater would be replaced with a heat pump water heater, as you can see on the screen from these two pictures. Both heat pump water heaters and heat pump HVAC are energy efficient and help us use less energy at home, which then reduces greenhouse gas emissions annually, while also reducing the local impacts of climate change. Hannah will be launching a poll here.
Sorry, I was muted. So here's our third poll. We just want to know who of those who are attending, what types of fuel heat your home, heat/cool your home, and heat your water. And we've got about everyone that's responded, so I'll just give folks a couple more seconds. Okay, thank you to those who responded. Yep, so a lot of natural gas. And feel free to, if you answered other, to put what fuel source or type you do use. It's good information for us to have if you're comfortable sharing it. Thank you. You can use the Q&A to type your answers also.
All right, so now let's get into heat pump water heaters. So heat pump water heaters are different from conventional gas water heaters because they don't generate heat. Instead, they transfer heat to warm water. Since they don't generate heat directly, they are 3 times more efficient than conventional gas water heaters that require a lot of energy to heat water. Heat pump water heaters also allow you to preheat water during the day when electricity rates are cheaper, so that you can store it and use it during peak times when rates are higher. And this helps reduce energy consumption by up to 60% and provides energy cost savings. On average, a family of 4 can save up to $350 a year on their energy bills when they upgrade to a heat pump water heater. Heat pump HVAC appliances also transfer air to cool and warm buildings. To cool a home, these systems absorb the heat inside your home and release it outdoors, and the opposite occurs when warming a home. Conventional gas-powered systems for heating and cooling also use a lot of energy for combustion to provide a home with a desired temperature. Because heat pump HVAC systems do not use this method, they can reduce energy consumption by up to 50%, and they can save buyers 20 to 70% on their annual heating and cooling bills. For this next set of slides, we will discuss the costs of heat pump water heaters and heat pump HVAC systems, the local, regional, state, and federal funding opportunities for these appliances that help cut the upfront costs of installation, and the co-benefits of these appliances. If you look at the figures on the slide, you see that for a single family home built before and after 1990, installing heat pump HVAC over a central gas AC system is more affordable. The same may not be true for heat pump water heaters, but there are health and safety benefits to consider with this technology that will be mentioned in the next slide. A big takeaway from this slide is that a window AC will always be the cheapest option for cooling, but they work better to cool smaller spaces, so you don't get a whole house cooling effect and comfortability with these most times. An additional upfront cost to consider is an electric panel upgrade, which may or may not be necessary depending on your energy load. And all of the prices on this slide, these are just estimates. And as a reminder, heat pump water heaters are 60% more efficient than gas water heaters, and heat pump HVAC appliances reduce energy consumption by 50%. So since you're using less energy to heat your water and cool and warm your home, you will experience monthly savings on your utility bill. When we look at upgrading heating and cooling appliances as well as water heating appliances in multifamily housing, we find that heat pump water heater upgrades are more expensive for multifamily homes built before and after 1990. Installing heat pump HVAC is also less expensive on homes built after 1990. Most of the times, these upgrades will need a panel upgrade, and this adds to the upfront cost of electrification. And the numbers you see on this slide include installation costs, equipment costs, labor costs per unit. So if a multifamily housing building has 20 units, then this number would be multiplied by 20. Since these appliances, heat pump water heaters and HVAC, are more energy efficient, there is a decrease in long-term operational costs to the building owner that can help to offset the upfront capital invested into those upgrades. There are also additional direct and indirect co-benefits that installing a heat pump water heater and heat pump HVAC system provide that their gas counterparts do not. The first is reduced energy cost, which allows you to spend less money on your energy cost monthly, which means you can use this money for other important things. There's also less gas exposure. That means that you and your family will not be breathing in toxic chemicals daily, and the possibility of a catastrophic event such as a gas leak is eliminated. And the installation demand for heat pump water heaters and HVAC, as it increases, this increases the demand for electrification jobs. This allows more individuals to come into this job market. And as we increase energy efficiency locally, we reduce the stress on our grid, resulting in fewer power outages, which is important during peak demand and extreme weather events. There are also funding resources to help with the upfront costs of these appliances. Bay Rent, for example, has heat pump water heater and HVAC incentives for single family homeowners, for multifamily, they're a multifamily program. And the great thing about their multifamily program is that the assistance they provide for heat pump water heaters and HVAC is per unit. So if you have 20 units, again, you would get the maximum, which is $750 per unit. So that's how that would work. There's also state programs like Tech Clean California that also help single family and multifamily homes with these upgrades. The California Low Income Weatherization Program focuses specifically on low income housing and helping low income housing property owners complete these upgrades. Bayron also offers microloans to commercial businesses. And a very new, exciting funding opportunity is actually coming from the Inflation Reduction Act, which is federal. And the Inflation Reduction Act is going to provide direct rebates for families to upgrade to heat pump water heaters, to heat pump HVACs, and also assistance to upgrade their electric panel. And I encourage you to visit the link on this slide to get a sense of the funds that you may qualify for. For these next set of slides, we're going to outline the potential greenhouse gas impacts from this policy, what other cities are doing to electrify residential buildings, and barriers and solutions by housing type. To analyze the potential greenhouse gas emissions reductions from this type of policy, we looked at issued permits for water heater and furnace replacement within the last 3 years, and we took an average. These averages are presented in the table on this slide. And in case you're wondering why we chose the last 3 years, it's because, COVID happened and a lot of life stopped. So we wanted to get as accurate as data as we could for what we could expect annually moving forward. We did not break these down by building type because we wanted to get an overall sense of how many water heaters and furnaces are being replaced annually and what the impact would be if they were replaced with heat pump water heaters and HVAC. So for the purposes of this analysis, we assumed that these furnaces and water heaters would be replaced with heat pump HVAC systems and heat pump water heaters. And what we found is that we have the potential to avoid over 7,000 metric tons of natural gas emissions a year from buildings if we adopted a replace at burnout policy, and these permit trends that we've seen in the last 3 years remain constant. This is equivalent to taking 1,500 gas-powered passenger vehicles off our road. However, over 7,000 furnaces and 13,000 gas water heaters are reaching their end of life annually and need to be replaced. And we need these to be replaced with heat pump water heaters and heat pump HVAC appliances to get the most natural gas emissions reduction from buildings each year. Right now, we're not close to those numbers, but we believe a lot of this work goes unpermitted, and there just may be a lack of understanding that furnace replacements and gas water heater replacements actually need to be permitted. San Jose is not the only city in the Bay Area that's working to electrify its existing buildings. A lot of cities around the Bay Area have mandated that all new development be electric, and now they're looking at which approach to take to electrify their existing buildings. The city of San Mateo, for example, is replacing a policy that it is proposing a REACH code for home renovations that will require heat pump HVAC when a renovation project in a single family home and duplex is replacing their air conditioning in conjunction with the furnace replacement. So they've taken the replacement during a major renovation policy approach. The city of Half Moon Bay also proposed a REACH code that would have required residential and commercial buildings to replace their gas appliance with the electric upgrade once it stopped working. And their proposal was also going to prohibit owners of existing residential buildings from adding gas lines. So the city of Half Moon Bay was proposing a replace at burnout policy. The city of Palo Alto was also proposing a new REACH code, and their REACH code would require heat pump water heater installation when gas water heaters are replaced as part of a renovation project. So again, requiring upgrades during the time of a major renovation. And the city of Berkeley is planning to propose both a replacement during major renovation and burnout in 2027, sometime in 2027. They did release a plan, and the goal of the plan is to implement a requirement for these upgrades, but they're doing it in phases. So most of the efforts are focused on phase one, which is just getting a lot of community outreach and education, financing opportunities, workforce development, and having all these strategies in line before their policies are brought forth in 2027. On this slide, you see the four most typical barriers to existing building electrification. And these are the costs to electrify, the lack of awareness of options that exist, the permitting process, and issues with point of sale. The potential solutions are highlighted in green on this slide. The cost of heat pump water heater and HVAC is a barrier, and this can be addressed when leveraging incentive funding. And the best way to make this connection for the resident would be to provide their incentive information when their contractor or the resident themselves are pulling their replacement permit. This helps to boost awareness around incentives, but also designing a contractor list of folks who can do this work and providing this to the resident is also necessary to help bridge that education gap and to just help folks understand what the first step in the process is. The permitting time for projects in the city can also take a while, and the best way to overcome this would be to allow the mechanical, plumbing, and electrical permits to be pulled at the same time to make it easier for the contractor to complete the project in a time frame that is reasonable to the resident. There's also an option to design an online permit system, a user-friendly online permit system with a 24-hour turnaround time. And finally, since we are focusing our research and analysis on single-family, multifamily, mobile home, and commercial buildings, at the time that any of these sell, the cost to upgrade the water heater or furnace will become a future cost to the buyer, and a home energy assessment would help prepare the buyer for these costs down the road. In the last slide, we talked about the most common barriers that all sectors face. And while they do share those common barriers, there are additional barriers that are specific to multifamily homes. For example, the upgrades that property owners of multifamily homes make, they must result in decreased operational costs. Otherwise, it's not motivating for them to make this investment to upgrade their buildings. And mobile homes are not affected by local building codes. So this means that mobile homes are not affected by any sort of policies that the city passes. So we would need to understand how to influence these upgrades while also addressing the barriers in the last slide. Now Hannah will be launching the last poll for this webinar before we move on to our Q&A.
So going off of the past couple of slides, we want to ask you, in your opinion, what the biggest barriers would be to adopting a policy such as a replace on burnout policy. And I saw someone put another barrier in the Q&A. If you answer other or have, if you have other concerns that you'd want to share, feel free to put them in the Q&A as well. And I'll give folks about 15 more seconds, 15 to 20 more seconds to answer. Okay, thank you. Everyone responded, and these are the results. Yeah, so definitely cost that makes sense, and understanding the process, kind of going or in tangent with finding a contractor to do the work that also understands the technology, et cetera. So thank you for your responses.